It is always good to see a model other than Transformers architecture. In this video, I am going to show you a model which is not Transformer but rather a hybrid of Transformer and state space. This new state space model or SSM is called as Zamba 7 billion version 1. Before I give you an intro of this model, let me try to explain what exactly is meant by state space model and how it differs from a transformer model. A state space model is a type of machine learning architecture that uses a combination of recurrent neural networks or RNNs and linear state space models to process sequential data. It represents a system's dynamics using a set of states and observations and uses Bayesian inference to learn the parameters of the system. This allows for efficient and scalable modeling of complex systems and is particularly useful for tasks such as time series forecasting, control systems, and robotics. The way it differs from Transformers architecture is quite interesting. There are few key differences here. First and foremost is sequence processing. State space models process sequences using RNNs, while transformers use self attention mechanisms. Then the second difference is around modeling dynamics. State space models explicitly model the dynamics of the system, whereas transformers focus on pattern recognition and attention. And in my opinion, this is the most glaring difference out there. Another difference is around scalability. SSM or state space models can be more efficient and scalable for long term dependencies and large data sets. And then we have interpretability. SSM provide more interpretable results as the states and observations have physical meanings in the context of the system being modeled, whereas the transformers are not that much. So at a high level, in summary, state space models or SSMs are designed for modeling complex systems and dynamics, whereas transformers are designed for pattern recognition and attention in sequential data. Now you know that what SSM models are and how they differ from state space models. Let's have a quick look as what exactly this Zamba 7 billion version 1 is. Zamba is a 7 billion Mamba based SSM with a novel global shared attention architecture. I already have covered Mamba model in detail in various videos on the channel, so if you're interested, please search it. The interesting thing about this new Zamba model is that it was trained on only 1 trillion tokens of open web datasets, and yet its performance approaches that of the leading 7 billion transformer based models. If you look at its architecture, that is quite interesting. Its unique architecture combines a Mamba backbone with a global shared self attention layer, merging the benefits of transformers for retrieval and in context learning with the inference efficiency of Mamba. This architecture provides a way to boost performance at a small and constant parameter and hence memory cost. Zamba is also the highest performing SSM in the small 7 billion model range and the highest performing dense SSM model available. Zamba matches state of the art 7 billion models on many linguistic evaluations, while lagging slightly behind on tests of reasoning and in context learning, which may be due to the significant data disparity between Zamba and other leading 7 billion models. Also, another interesting fact is that this new architecture, which you see on your screen of Zamba, was inspired by the relation between the cortex and hippocampus in the human brain, where different layers and regions of the cortex, despite performing different tasks, all send and receive information from a single shared memory store in the hippocampus. Also, their core concept of shared layers allows them to spend additional flops to improve performance is closely related to work on recurrent models or RNNs, which share deep similarities to neural processing as I mentioned earlier. The training of Zamba is also quite interesting. They have trained Zamba in two-phase approach utilizing a general pre-training and annealing phase on a high-quality dataset coupled with rapid learning rate decay. Also, they have found it better to reform the learning rate followed by rapid exponential decay. And they have also found out that this significantly improves the performance of their model upon downstreaming evaluations, but has little effect on others. If you look at this architecture on the screen, Zamba consists of a backbone of standard Mamba blocks connected to a shared attention and MLP block. This block is repeated every 6 Mamba blocks but has shared parameters, which enables Mamba to utilize more flops for increased performance at the same memory cost. The input embeddings are always concatenated with the residual stream going into the shared attention block, as this provides an additional path for the model to remember the inputs. After the block, a learned linear projection maps the output back to the residual system. So if you summarize this whole Zama thing, you can summarize in two features. First and foremost, this is a state-of-the-art transformer SSM hybrid architecture at 7 billion scale that preserves the flop efficiency of SSM as well as the in-context learning ability of attention. Then it's a new neuroscience-inspired shared attention optimization that preserves the modeling performance of independent attention blocks while saving money. Successful replication of two-phase training method in a large-scale model is evident throughout the paper, which you can also read in their model card. So all in all, this amazing model is out there, which you can try out now. One thing to note down is that if you're looking to implement it, then you would have to fork the existing transformers into transformers underscore Zamba. So if you go to the model card and scroll down, you will see that you would need to clone this instead of the typical transformers library, and that is the key there. So make sure if you're trying to install it locally, you do that, and you would need a good GPU in order to play around with this. Also, with Zamba, by both validating the performance of Mamba at scale and by pioneering this new architecture, they have also taken a step towards moving away from the standard transformer architecture for training state-of-the-art models, and that is very, very interesting. The researchers in this paper believe that architectural innovations are relatively understudied given the success of scaling paradigm. And another cool thing is that with Zamba, they have made available all the checkpoints during both a pre-training and annealing step, one every 2500 step. And many scientific questions of deep interest for understanding the learning dynamics of such models can only be approached by studying the evolution of model weights during training and few academic groups. So amazing stuff. I'm really thrilled by this model. I don't have the exact GPU card to run it, otherwise I would have shown you the actual loading. But if you have the GPU of a good strength, try it out and let me know how you go. If you like the content, please consider subscribing to the channel, and if you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.